Welcome everyone to National Astronomy Week. This may be your first time to our daytime sessions, so welcome to Zoom, or if you're watching on YouTube Live. And there are some classes out there and homeschool groups, you know who you are, who have been to pretty much all of these. So thank you so much for joining us again on this Friday. Now, National Astronomy Week has been a week all about encountering Mars. It's really close to us. It's really close to planet Earth at the moment. Closer than it will be again until 2035, when you guys are all going to be 15 years older and wiser. So it's something you can see in the night sky tonight. Now, it's not quite this big. If you have a look behind me and Jackie, that would be petrifying. So it's not quite that big, but if you do go outside, have a look for a really bright orangey star-like object up there. You pretty much can't miss it. So check outside over the next nights, well, when it stops raining. Okay, anyway, back to business. Astronomy Week has been great, but it doesn't just have to be a week. It could be a life of space and astronomy discovery, and that's what we're talking about today. My name is Sharon. I work with science centres and planetarium domes across the UK. So I work in space education, and I'm joined by my friend Jackie.
Thanks, Sharon. Hi, everyone. My name's Jackie. Some of you may have met me on Tuesday if you tuned in to learn more about Mars with Joe and Anya. I'm a senior teaching fellow in the Department of Computing at Imperial College London. And in my spare time, I'm also training to one day become Britain's next astronaut. I'm super excited to be here today to hear from our special guest and to see all your questions coming in. Hopefully, we'll get round to answering them all.
Thanks, Jackie. Now, I have got, some of you have already started putting questions in the Q&A box. So down at the bottom of your screen, there's a couple of bubbles. You can type away your question in there and it pops up on our screen. This just did go into nowhere. It pops up on our screen. Now, today, we are going to try to see if some of you might be able to ask your questions live. So if you put your question in the Q&A first, and then when we get to the question section, we will ask you to raise your hands in the attendees, and anybody who's got a microphone, we'll see if we can unmute you so you can ask your questions to our guests. So our speaker coming up, I'm going to pass over to Jackie just to introduce who we've got for you today.
Thanks again, Sharon. So our guest speaker today is Sophie Allen. Sophie's a good friend of mine and Sharon's, and she's head of teaching and learning for the National Space Academy. Now, the National Space Academy links students, teachers, and the space industry together through masterclasses, teacher CPD, and their own innovative space engineering course, which is super exciting. I wish I was young enough to go on that course, all through the exciting and ever advancing context of space. So Sophie's developed educational activities with a huge range of organizations, including the European Space Agency, and has a passion for encouraging as many young people as possible to follow their love of space into an exciting and fulfilling career. Now, I always learn something new when I talk to Sophie, and I can't wait to learn more about space careers today. So I'm now going to hand over to Sophie to tell you more. So Sophie, over to you.
Fantastic. And good morning, everybody. Morning, Sharon and Jackie. Lovely to see you. Hello, everybody at home, everybody in school. Really looking forward to chatting to you about space careers. So a lot of people don't realise that the UK has a really active space industry. There's loads of really interesting jobs out there for people who have the interest and are willing to put the work in. But sometimes you have to be told what these jobs are. I know when I was about your age, I was really interested in space, but it didn't seem to me like working in a space job was something I'd be able to do. It wasn't until I went to Space School UK that I started to realise there were lots of different jobs that I could potentially get involved in. And through my work with the National Space Academy, I've been lucky to work with a huge range of people doing really exciting space stuff. So in this session, I'm going to be chatting to you about some of the cool careers that there are at the moment to do with Mars. I'm just going to share a presentation with you with some pictures. And rather than just talk about the careers, I'm going to introduce you to some of the people that are doing these jobs, some of the people that I've had the chance to meet and work with, and hopefully get you thinking about what your next steps might be to set you on a path towards a space career. So there's a lot of hype about Mars at the moment. We're sending loads of stuff there, and many different space agencies, including NASA, the European Space Agency, the Chinese Space Agency, are genuinely working at looking at ways to send humans there in the future. And so Mars itself is a really interesting planet to us. It's very close to us, as Sharon said, about 1.5 times further away from the sun as we are. But the surface itself doesn't look so planet-like. It looks a bit more moon-like. It's very dry. It's got loads of craters on the surface. So why are we so interested in it? Well, one, it's there and humans explore. It's what we do. But two, we're pretty sure that in Mars's past, it would have had water. There are surface features that, unlike this dry, arid landscape that we see today, we see evidence of rivers, we see evidence of previous oceans, and we know that here on Earth, anywhere where there's water, you're likely to find life. Also, humans explore. We might want to be setting up research bases on Mars. We might want to be expanding our civilization. But if we're going to do that, we need a huge number of people doing really interesting jobs. And the first thing we need to think about is getting there, getting to Mars in the first place. Now, traditionally, we use rockets like this. This is a Russian rocket called a Soyuz FG. This is what launches humans up to the International Space Station. It's one of the launchers. But here in the UK, there's some really exciting work that people like Baldeep are doing. Baldeep works for a company called Reaction Engines. He is an engine technology technician. He didn't do a degree. He decided that he wanted to go straight into work, learn on the job, and be an apprentice. And he is helping to build this. This is Skylon. And Reaction Engines are aiming to make this the world's first space plane. It acts half as a plane and half as a rocket. So it takes off like a normal plane. And the advantage of that is it uses a lot less fuel. It's a lot more economical, it's cheaper, and it's better for the environment. The Sabre engine that will power it, when it gets high enough in the atmosphere, then kicks into rocket mode. It starts to use fuel and oxygen together to get a really big push to be able to take this space plane up. And so Baldeep is one of a team who's working right at the cutting edge. Nothing like this has ever been built before. And it's being built and tested right here in the UK. Once you've managed to get there, the first step when you're going to another planet or a moon or anywhere in our solar system is to observe it, to look at it, to see it from orbit. And that's what this craft here is doing. This is a satellite called Mars Express. It's been up there for quite a long time now. It's getting quite old. It's getting towards the end of its life, but it's done some really amazing things, as have the team who have worked on it. Now, the gentleman with the fantastic facial hair there, that's my friend Simon, and the guy below him is my friend Tom, and they both work for the European Space Agency. The European Space Agency is made up of lots of different space agencies from across Europe and some partner organisations like the Canadian Space Agency and the Norwegian Space Agency. And so being here in the UK and being part of this system, part of this big group, means that if you're young and interested in science and think that you want to do some cool space stuff, you might get to go and work for the European Space Agency. Now, with lockdown and with COVID, one of the things that I found really funny is that Simon, the guy with the fabulous facial hair, he's actually been controlling this Mars Express satellite from his sofa at home. He sits there with a laptop connected to the European Space Agency systems, and he's literally telling this satellite that's orbiting another planet what to do from his sofa. I don't get to do anything quite as fun as that, but it would be pretty great to be able to. And the really exciting thing that Mars Express has done is using radar, it's been able to find evidence of liquid water below the surface of Mars. So again, if we're looking at sending humans there, we want to find liquid water. And the fact that this special satellite has done that, even though it's coming towards the end of its life, is really exciting. And it's being done by UK scientists who are getting to work with the European Space Agency. So once you've looked at the surface of Mars from your orbiting satellites, then we want to start to get a closer look. We want to be able to start to dig at the surface, poke it and prod it, see what the surface of Mars is made of, see what the conditions are, see what we might be able to find, and potentially even look for signs of life, either past or potentially present. Now, the problem with Mars is because it doesn't have a thick atmosphere like the Earth, it's getting slammed by radiation. And we think that if there is going to be evidence of life, it's probably not going to be just lying around on the surface. We're probably going to need to dig down. And no one's done that yet. But this mission here, called ExoMars, this is the Rosalind Franklin rover, which will be hopefully launching in a year and a bit. This has been worked on by people like my friend Abby here. Now, Abby works for a company called Airbus based in Stevenage in the UK. And in the back of the picture, you can see a Mars rover. It's a prototype, or they call it a breadboard. And so what Abby and her colleagues do is they build test rovers to test the cameras, the experiments, to make sure all the electronics will work. And they do this in a fake Mars environment. This is their Mars yard in Stevenage. Here we've got Bruno and Bradley, two of the Mars rovers. One of the coolest things about Abby's job is she actually gets to control them and drive them around the surface using a PlayStation 3 controller. I've had a go myself once, very, very briefly. It was extremely fun getting to drive a prototype Mars rover around. Once all of the things have been tested and they look to see how is the extreme cold on the surface of Mars going to affect the rovers, are they going to be able to get over the rocks well? Is there no chance that our rover is going to get stuck? That's when they can then build the final rover. And what ExoMars is going to do is it's going to drill down 2 meters below the surface. It's going to take soil samples and bring them up. And it's got a little mini laboratory on board that it's going to use to test these samples and potentially in the future take some samples that could be used for other missions. So Abby's got a really, really cool job. She's an engineer by trade. She went to university to do that. She studied engineering. And the good thing with the ExoMars project is it should go on for a long time. She will spend probably about half of her career working on this project. So it's really, really cool project to be working on. I'm a little bit jealous of Abby, I have to admit. Another cool job that you can do in the space industry, and I think this, for me, sounds about the coolest, is an astrobiologist. Now, an astrobiologist is basically a professional alien hunter. I don't know what you folks at home and at school think about the likelihood of finding aliens out there, but if you love biology and if you're interested in everything that it takes for life to happen, what life needs to survive, what we need to be looking for if we go to other planets and other moons, then maybe astrobiology would be a good career for you. This is my friend Lewis, and he is an astrobiologist who started his life out focusing on Mars. In fact, when he was doing his PhD, which is what you do to become a doctor in science, his PhD thesis or big project was called Martian death rays, because he was looking at how Mars would be affected by all the radiation that's hitting the surface and what kind of things might be able to survive on that surface. Now, it's difficult to get out to Mars. It costs a lot of money. We do have things on the surface, but we have to be really picky about the experiments we send. So what astrobiologists do is they go to places like this. They go to places on the Earth where the most extreme life can survive. Now, this pool here is in Yellowstone National Park, and that is on a really big volcano, a supervolcano. And what happens with these pools of water on this volcano is you get carbon dioxide bubbling through the water, you get sulfur dioxide bubbling through the water, and you get a lot of heat. And that makes extremely hot and very, very acidic pools. And it looks like the kind of thing you might want to jump into. But unfortunately, in 2014, a tourist had a go at that. And the heat and the acid caused him to dissolve. It's a little bit of a gross tale there. So it sounds like this is the kind of environment that you wouldn't expect to find life. Really hot, really acidic, really inhospitable. But when astrobiologists have taken and analysed samples of this, what they found is that actually life does exist here. Small microorganisms, little living things that are too small to be seen with the human eye, but they are living things. We call these extremophiles. And so astrobiologists look at all of the different extremophiles here on Earth. They study them, they find out how they can operate, how they can work. And perhaps more importantly, they start to set limits about what's the best and worst environments for life to be able to survive. They then go, okay, so if we are going to Mars, where it's very dry and there's a lot of radiation, then we might want to be looking at the kind of life that can survive out in desert areas where you'll go for months without any rainfall. Probably an astrobiologist's favorite microorganism is, oh, it's disappeared, that guy there. I can't show you the picture. For some reason, it's disappeared off my slide, but I can show you the experiment we did. There's a creature called a tardigrade or a water bear. Tiny little microorganism, really small, and probably the toughest thing on this planet. It was taken up in a mission called TARDIS, which went up on a Russian Cosmos vehicle. And in this experiment, those little tiny tardigrades were exposed to the space environment. No oxygen, no air, radiation, extremes of temperature. We expected that they probably would have died. But when this was brought back to Earth and the samples were brought into the lab, after a few hours, these water bears reanimated. They came back to life. Somehow they put themselves into a state of extended hibernation and have been able to survive that extreme environment. So what people like Lewis are doing is they're looking at tardigrades and they're saying, okay, well, if a creature like this can exist and survive on Mars, or at least evidence of it could exist on Mars, what experiments do we have to do to find it? So if biology and looking for life in the universe is your thing, then it might be that astrobiology is the job for you. Now, when we're looking at doing all of these space exploration missions and sending people to space, we need to think, okay, how are we going to make sure everyone is safe? And how are we going to make sure that space is explored in a fair way? And typically when you talk about space careers, people think about scientists and engineers, but there's a lot more to exploring space than that. So people like Joanne are actually space lawyers. They have done their law degrees, they've done some law practice, they've understood how the laws work, and then they start to write the laws that are important for making sure that space is explored in a safe and a fair way. You might want to have a think yourselves about what you think the most important things to protect or to discuss when it comes to space law are. Everything from which countries should have access to mining resources, from health and safety to make sure that astronauts are protected when they go up there, to defense of our Earth from, meteorites and things like that. All of this comes under space law. And this is a very young, very new area. But just as the space industry is growing at an increasing rate, so are the need for people like Joanne, who can take Earth jobs and spin them to a space job. And it's not just law. If you can think of a job that you can do here on Earth, there's a space version. One of my friends is an accountant for a space company. So she is managing all of the accounts and working out how they're spending their money on their research and their tech. Computer programmers are needed to be able to write the programs that do this. We need doctors and nurses to monitor how our astronauts are when they are up in space, particularly if we start to send humans to Mars. If you can think of a job on Earth, there's a space version of it. And I really love the idea that in order to be able to get into space, you've got all these different roles, but you're still working in the space industry. And here on Earth, we can do a lot to prepare us for missions into space. So here on Earth, we have lots of researchers, mainly planetary scientists. So what we do with planetary scientists is we take what we know about our planet. What is the structure of our planet? How does our planet work? How do all of the different parts of our planet, like tectonic plates and atmospheres and interaction with water, how does that drive events on our planet? And they explore this. So what planetary scientists do is they look at very similar areas on Earth to planets and moons and start to investigate it. Now, I believe actually Lucinda, who's on the call with us here, you're in this picture, aren't you? This is the Mars Desert Research Center in Utah.
Yeah, that is. Hi, I'm the executive director of the Mars Society, and we have two habitats. This one is in Utah. This is the Mars Desert Research Station, which has a green hab here, and you see an observatory off to the left. That was actually donated by Elon Musk way back in, I think, 2002. And those are two Marsonauts that are conducting field work while in simulation. So they basically live in the hab on the right, and that's 2-story habs outfitted with science labs and a place for them to sleep and a kitchen for them to eat and workspaces with computers so they can talk to mission control. So they simulate living and working on Mars. And we do that here on Earth here at this habitat in Utah. And we have a second habitat in the Arctic, the high Arctic on Devon Island, which is called Flashline Mars Arctic Research Station, which is a lot more remote. This one you can drive 10 miles down the road to find, but the one in the Arctic, you have to take a flight, a Twin Otter flight that can only carry so much mass. So it's a lot more remote, which allows for a lot more autonomous living and working, just like you would be if you were living on Mars, because it would be difficult to communicate with them when they're far away on Mars. So we have to simulate that. What would that be like? But thanks, Sophie.
Fantastic. Thank you, Lucinda. And I didn't know, honestly, I didn't know before I put this presentation together that Lucinda had this was her project and that she'd even be here in this image. And so this really typifies what a lot of space work is about. It's about international collaboration. It's about working with people across the planet for a combined common aim of exploring space. And, you know, you can be a geologist and learn about our Earth, which is amazing and fantastic. But then you can adapt that and become a space geologist, a planetary scientist, and look at taking those same techniques and what we learn from those techniques and adapting them to exploring places in the future. Now, I can't talk about space careers without mentioning this person here. This person is Tim Peake, and he was the first government UK astronaut. So here in the UK, we have our own space agency, the UK Space Agency. And that agency oversees all of the space activities that we do, everything from spaceports that are going to be being built soon and launching small satellites into orbit around the Earth from the UK, to the research projects that we're taking part on, like the Lunar Orbital Gateway, which is going to be a research station in orbit around the moon, to the astronauts that we're able to send up like Tim. So Tim is a European Space Agency astronaut, and of course he's had the opportunity to go into space and to experience weightlessness, to experience the views of space, and to be able to get up there. And I'm sure there'll be loads of questions about what you need to do to be an astronaut. I know that Jackie will be really good at helping us to answer those questions because she's well on the path to that at the moment. But the key thing about people like Tim and all astronauts is you don't leave school and become an astronaut straight away. You do something else first. You might be a scientist, you might be an engineer, you might be a doctor, you might be a teacher, you might be, as Tim was, in the military. Because if you're going to send humans into space, you want them to be mature, you want them to have a lot of world experience, you want them to be great communicators, and you want them to be really good at working with other people. And you gain those skills through jobs that you have. So if anyone there is thinking they want to be an astronaut, start off by thinking, if I'm not an astronaut, What else would I like to do? That's the way to make sure that you can go in that direction. Here we've got a picture of Tim during his spacewalk, and you can see we've got the solar panels of the International Space Station. So the International Space Station is in orbit around the Earth, and it's basically a giant orbital laboratory. And all across the UK at universities and companies, there are people designing experiments to go up there. I've been really lucky to work on some educational experiments that we launched up to the International Space Station. And there's an awful lot of testing, even something like a small set of educational experiments. We were working for a year and a half to develop them, to test them, to make sure that they wouldn't be a danger to the astronauts or the space station. We had to work with people from the European Space Agency, from the Russian Space Agency, Roscosmos. We got to go to Holland, to ESTEC, to test these things and try and shape them to part, to simulate launch. But again, it just really shows how international space careers can be, and how we need to work with people from different companies and different countries to be able to explore space well. Now, at the moment, we only send humans to the space station. But if in the future we are going to send humans to Mars, then that means eventually all these jobs that we have here on Earth, we might need to send people to do those jobs on Mars. It's a really, really exciting time for humans. And as Sharon mentioned at the beginning, in 2035, that's when Mars is next going to be closest to the Earth. That's in 15 years. So that means there's some people watching this now that might be in a science, a maths, an engineering, a technology career, who might then have the opportunity to be working on missions that will be going to Mars then. Because we can send things to Mars every couple of years, but we'll send a lot of things in at 2035, because when you're closer, you use less fuel. So good opportunity coming up for you guys at home. But the main message that I really want to bring to this is that you can't do anything in space on your own, whether it's sending robots or satellites, whether it's building space planes, whether it's sending humans out there. You need a huge team to be working on it. And everything from design and concept and talking about the ideas to space artists who make the visualizations and make the amazing pictures that we see of things before we've had a chance to go there ourselves and explore it. All these people are working together to get these amazing missions done. And so the most important skill that you will need to have or develop if you want to work in the space industry is going to be teamwork. Take every opportunity you have as a young person to get involved in stuff and to work with other people, develop skills, and to make sure that you're giving yourself the best chance to have a space career. Now, there's lots of other space careers that I can talk about, and I'm sure we've had lots of questions about space careers as well. So as we have our conversation on the questions, I will bring a few more bits into it. But I want to leave this part of the presentation on this message. Every single person I've shown you in this presentation was once just like you. They were in school, they were interested in space, they were probably interested in science as well, and they wanted potentially to do something in space. And now that you know that these space careers are an option, you can start looking at what you might need to do them. Now, I'm sure some of this will come up in the Q&A, but if you're interested and you want to find out more about some of the amazing space careers that might be open to you, there's a website called Space Careers UK. It's run by a group called UK SEDS, UK Students for the Exploration and Development of Space. They're partnered by the UK Space Agency on this. And on this website, you can do quizzes to find out what your perfect space job might be. You've got profiles of people that are doing these jobs right now. And it's a really fantastic resource for you to get more information about how you could maybe get a job in space. So that is the end of my presentation. I hope that's been interesting. And we've got plenty of time now to answer some questions. So I'm going to stop sharing my screen now. And Jackie, are we ready for some questions?
Brilliant. I think we are. Thank you so much, Sophie. That was amazing as always. I was trying to write notes with all the things I've learned today. So we've had a question in from Holy Cross Primary School, which is asking, so I know that in the UK we've got plans to, you know, introduce space tourism in the near future, fingers crossed. But how long until we let the general public go into space?
Oh, so
Yeah.
the main thing this boils down to is that kind of space law idea again. So we have the technology to do it. There are companies like Virgin Galactic who are working on this. Blue Origins are working on you know, kind of the idea of taking tourists into space. We do have the technology. What we need to do before we start sending civilians, so non-astronauts, into space, is make sure, A, that we've done enough tests to know that it's going to be safe, and B, to put all of the laws into place to make sure that you know, people and the organizations are protected. So if you talk to people like Virgin Galactic, they think that they will be taking space tourists up within the next 2 or 3 years. We are looking at really quite imminent. If their plans go ahead and if they can pass all of the laws, we're looking at not long before you might be able to buy a flight into space. And these flights, they're not going to be going into orbit, but they are going to be going into kind of, well, just about suborbital flights. So you'll just cross the space line. You'll be able to tell people that technically you're an astronaut, but you'll take a short flight up on a big curve. You'll get to float around for a little bit in microgravity, look out of the window at the Earth, and then get back safely to the planet without having to do anywhere near as much training as the astronauts. So it is a really exciting time. As soon as it comes into my price range, I'm not kidding, I am getting a ticket, because
Yeah.
yes,
This is what I was going to say. Like, as soon as it's affordable, I think we'll all be queuing up to do it. And the fact that we might, you know, one day have an opportunity to fly from the UK as well, it means we don't have to, you know, go over to America or any of the other traditional launch sites.
The other exciting thing is that because SpaceX have been launching their new crewed craft, so just a couple of days ago we had the second crewed launch that had 4 astronauts on, one from Japan, and it was the first launch of a female astronaut from US soil since the shuttle program. And what that's going to do is, at the moment, until now, we could only launch 3 astronauts into space at a time. And so that meant that those spaces really had to go to astronauts who were fully astronaut trained, who would spend 6 months up there and would be doing research. Now, once SpaceX is at full capacity, we could be taking 7 people up to the space station at a time. And so that also means that they're looking now, and NASA is working in partnership with various different companies to make this happen. There will be a point quite soon where you'll be able to, if you have enough money, buy a ticket, go up to the International Space Station and actually stay on the space station for a week or a month or a couple of months. And that, to me, is a really exciting prospect as well. They're even talking to Tom Cruise at the moment about filming the first film actually in space. Wow. And the idea is that he'll go up on the SpaceX capsule and he'll go to the space station.
Of
That's
course
really cool.
he will. Of course he will. Now, some of you are remembering that if you do have a microphone, you can put your hand up. We have had loads of questions in, and they're pouring in at the moment. So some of them will answer on typing. Some of them will try and see if you can answer yourselves as well. But for now, let's see if we can go to a question from Jarvis Brooks School, Year 5. Now, because you have your hand up, I'm going to try and unmute you. So let's see if this works and see if you can ask your question live. So,
Ready?
Year
Hello,
5.
Hello.
Hello.
Hi.
And
Hi.
here's Isabel with her question.
If we found life on Mars, what would we do?
Great
That
question.
is such a good question, Isabel, and it's a difficult one to answer because different people have different views on what we should be allowed to do. There's a lot of ethical issues with finding life on other planets. So some people say that if you find life on another planet or a moon, you should leave it be, let it do what it wants to do, let it, you know, come to its conclusion and go through with potentially evolution and things like that. There's other people that say that, well, we'd study it. You know, what we'd really want to find out, if we found life on Mars, what we would first of all want to find out is, does it have any similarity to life on Earth? And more importantly, could it potentially have come from the same place that life on Earth initially did? You know, is it a kind of space cousin to us? So studying it would certainly be something that we would want to do as well. It is a difficult topic. There's this whole area of space called planetary protection, where there are rules about what we can send. Everything has to be cleaned to make sure that we don't contaminate other planets with Earth organisms. But if we did find life on Mars, I think the first thing that would happen is a lot of conversation and a lot of discussion about what the best thing to do would be to go forward. Isabel, what do you think we should do?
Oh, she's sat down. She's coming back. She's coming back. There we go. Go on, Isabel.
I probably would say study it, probably, because it would be really cool if we found out like that we actually did have relatives in space.
Yeah,
I just said Isabel was Isabel wants to, you want a career in space science, don't you? So she's been glued this week.
Fantastic, Isabel. Well, check out that website and see all the exciting careers you could get involved with.
I think on that note, I know there's been a few questions about astronaut training, and I know, Sophie, you mentioned that, you know, before Tim Peake became an astronaut, he had another career in the military. And so there's a question here from Lilia, which is about what grades you need to work as an astronaut, and that she's always wanted to be one since she was 4. So I share that passion as well, and I would say that having a strong STEM background would be very good. So having a qualification in science, technology, engineering, maths, or medicine would be a great start. Trying to be interested in a lot of different things, so be a bit of an all-rounder, so take on a lot of different challenges, opportunities, do lots of sports, do lots of reading, just try and educate yourself as much as possible, because astronauts are people who have to multitask. They have to know a lot of things. You know, they go up to space, they're their own doctor, engineer, scientist. They have to do all the experiments, all the work, fixing things on the space station. So any hands-on kind of experience that you can get of fixing things would be great. So I guess it's not necessarily the grades that you get, but it's just the interest that you have in a lot of different things, and your passion for, you know, for all things space science. So I just wanted to add to that.
And you can fly a helicopter as well in your training. Now, what's that about? Because I remember when I worked with you, you were learning how to fly a helicopter, because that would help with astronaut training.
Yeah, so this was something that I never thought that I would get to do, because I guess some of the viewers tuning in today, I thought I would never get to fly. I didn't even know how to get a career in aviation. And then I saw that Tim Peake was picked. He had a great experience of flying helicopters. That's his area of expertise. And I know that I was talking to an astronaut, an Apollo astronaut, a few years ago, and they suggested that if I couldn't fly fast jets, then maybe flying helicopters was the next way forward. So I've been, as Sharon says, I've been learning to fly. There's been a bit of a break at the minute with the current situation, but I'm hoping to get back in the air soon. And for anyone who's interested in a career in flying, it's definitely possible. There's lots of scholarships there for you, so just check it out, check what you're available to get, and yeah, never think that you can't do it.
Amazing. Aim high. Right, we're going to go for another talky question. We're a hands up question. We have got Priory class, and I think they have asked so many different questions. So I don't know if it's possible to ask one or two of them, but can you speak?
We can. Can you hear us?
Yes, we can.
Perfect.
Hello, Priory.
Hello. Oh, we all going to say hello? We've been here all week, so we are very happy to be involved. We've got Jack here to ask a question. Go on, Jack.
What foods can you eat on the ISS, and what foods can you not eat?
Brilliant question. So the thing with the ISS is that the astronauts on board are in there for 6 months at a time, and it's a closed system. So the kind of foods that they eat are stuff that is really easily prepared. So they have food that is kind of pre-cooked, and they heat it up by either adding hot water to it or placing it in like a heater on board. But the main thing is you want food that isn't going to make a mess. Okay, if you're a messy eater, you have to learn not to be a messy eater to go into space. Because if you're eating something, even like a sandwich, and crumbs fly off in all different directions, those crumbs are just going to float around. They might get sucked into machinery, they might get breathed in by your crewmates. So the kind of food that astronauts tend to go for is stuff that can be eaten quite neatly. Things like tortillas. I know that tortillas with peanut butter and tortillas with guacamole and stuff that will stick to it nicely is really popular up there. The other thing that astronauts tend to eat a lot is quite spicy food. When you're floating around in microgravity, because the fluids shift in your body, you kind of feel like you've got a bit of a cold the whole time. And that means that your food doesn't necessarily taste particularly good. So astronauts tend to have food that's got a lot of flavor in it to cut through that. In terms of food that you are not allowed, the main thing is fizzy drinks. And the reason for that is if you're floating around in space, here on Earth, when you drink a fizzy drink, all the bubbles rise up to the top. And when you have a burp after a fizzy drink, all that gas comes out, everything's fine. When you're floating around in microgravity, those bubbles don't rise up. They kind of mix with all the food in your stomach. And as the pressure starts to build up and you need to have a burp, rather than just burping that gas, you burp part of your dinner as well. So yeah, ew. So as a result, things like fizzy drinks would definitely be discouraged on the International Space Station.
No way. No way. Lucinda in the background, I thought you were absolutely wanting to go into space, but I can see on her chat she's saying, no way, I can't live without fizzy drinks. Did that answer your question, Jack?
Yes, thank you very much.
Brilliant. We'll come to some of your other questions in a moment, but now we're going to do some quick fire because I can see there's dozens and dozens of questions. So let's take a few more.
Yeah, so we have, someone's asked about 2020 vision, whether you need 2020 vision to fly a plane or a helicopter. No, so you can get your private pilot's license. So that's where you fly yourself and you're not flying a commercial crew with glasses. So you can have glasses and still fly. So that's great. Have there been any home educated astronauts? This is a good question. I don't know. I think there might have been. Sophie or Sharon?
I'm not sure on that one either myself.
Yeah.
I don't see why. I mean, it certainly wouldn't be a barrier to being an astronaut, because all that is needed to be an astronaut, as we've said, is to be really good at something and to really, find a career you want to do and excel. And the good thing about home education is you have that opportunity to follow your passions a little bit and to really deep dive into things. So, if you go in those directions, it might even help you a little bit. You never know. So yeah, I don't know off the top of my head of any that are, but I certainly don't see any reason why they wouldn't be.
Yeah, I agree. I think there must be, the amount of people who've gone to space, there must be one who's at least been, educated during a primary or secondary school or at some part of their life. There's a few more questions about space food. So just to follow on from what Sophie was saying. So obviously fizzy pop is not ideal in space. Fresh foods as well aren't very good because they can just start rotting quite quickly. So you won't want any of them, but they do occasionally get sent up as a treat. But mostly you would be eating dried foods that you have to rehydrate, so you add water to them. And this makes them both light to carry up to space, because carrying things up to space costs a lot of money. So you want them to be as light as possible. A bit like trying to post something at the post office. You try and get the lightest packaging as possible so it's cheaper for you to send to your friends. So it's a bit like that. So it's mostly dried, that can be packed very, very tightly together and take up not that much space. There's a question come in. This is from Miss Taylor. So it says, when was Mars first discovered? Maybe who's best to answer this?
Mars was pretty much discovered as soon as the stars were.
Yeah, as soon as anyone looked up.
Yeah, as soon as people looked up, so the word planet comes from ancient Greek planetes, which means wanderer, because they were seen as these stars that seemed to move across the night sky really slowly. And very quickly people realized, hang on a minute, there's a red dot there and it's moving across the sky. But I think Sharon probably has a bit more information on this than I do. Would that be fair?
I mean certainly back ancient times they would notice Mars. So I suppose until it wasn't until we probably looked at it through a telescope, and there are all those stories about people starting to see lines on Mars, and everyone was certain that there were canals and aliens on Mars building those canals, and there was a whole a competition to find alien life. But don't worry about Mars, because we know there's alien life there. Let's look for alien life elsewhere. So but that was when the telescope was invented. So that's like 400 years ago, when they probably looked through a telescope at Mars and thought that they saw these things. But in terms of its discovery, you're talking back in the Stone Age, when people first looked up and noticed something in the sky. And certainly the ancient Greeks and the ancient Romans worshipped it as a god, in fact, the god of war. Because when you look at it tonight, it looks almost reddish, like a drop of blood in the sky. So there you go. Here's a question. Now I like this one, because this one's really, you were talking about all the massive diversity of space careers here, and not just diversity in terms of, if you're making food, you need like some kind of space chef or a space artist or a spacesuit designer, or that sort of thing. And then you were talking about teamwork, and that being probably the most important thing to work in the space agency, the space industry. So question from Tracy Watson was, well, how many people does it take to launch a rocket?
It's a really good question. So the Saturn V rockets that took humans to the moon for the first time in Project Apollo, 400,000 people were involved in that mission in total. If you include everything from janitors sweeping up in the various research places to, people, the Apollo spacesuits were hand sewn by seamstresses. So those spacesuits that you saw, Neil Armstrong and Buzz Aldrin wearing the first time humans stepped foot on the moon, they were hand sewn by a team of 14 seamstresses who were just really skilled at making clothing. Everything from that to the people who are, making the seats, who make the wiring to go in it, who put the wiring in, even on launch. So when the SpaceX launch takes place, you have got hundreds of people on site just to check everything's going all right. A team of 5 people getting the astronauts into the capsule at the top, a team of drivers getting everyone from A to B. So we're talking that even modern space launches involve thousands and thousands of people. And that's the really exciting thing about it. I mean, just in the UK, there are over 40,000 people directly employed in space jobs. And that's phenomenal, who have space in their title, who can say, I'm a space so-and-so, or I work for a space company. And that's just here in the UK. If you multiply that out through all of the other countries that do anything to do with space, and that number's growing all the time, huge numbers of people involved.
Wow. Now, I know that we're going to have all those extra launch sites in the UK as well. So there's going to be even more jobs opening up in the UK, which, all of you young people listening today will hopefully fill. So there's definitely a career in space science and engineering there. So we've had a question from Ava, and she asks, what happens to the robots when their missions are completed?
Yeah, that's a very good question. So far we've sent 6 rovers to the surface of Mars. At the moment, there's only one of them that is active, and that's the Curiosity rover. All the other rovers have reached the end of their life. Either they've stopped being able to make power to be able to, do things, or they have broken in some way, or they've been damaged in a Martian dust storm. And at the moment, what happens to them is they are just there on the surface. We're not able to communicate with them anymore. We can take pictures of them from orbit. There's a satellite called the HiRISE satellite, which can take really good quality zoomed in pictures. And so what the agencies do is every now and then they have a check-in, they take a picture, they check that the rover is still there. But effectively, when they come to the end of their life, at the moment, all we can do is leave them, you know, where they've stopped. Now, if I were setting up a Mars base in the future, I think I would probably go and get them. And I'd like to have like all of the rovers in a place where we can kind of thank them for their work and for the amazing work that they've done. Especially my personal favourites are Spirit and Opportunity, the Mars Exploration NER rovers, because they were only designed to have, you know, missions that lasted 9 months to a year, and they went on for 9 years, trundling across the surface, taking it. The fun thing is that even though they're now dormant, you can still see their tracks behind them. So when the high-rise imager is looking for them, you can kind of see their little track prints and monitor where they've been on the surface, which is quite cute.
Oh, that's really cute. And we've got a follow-up question about paint. So why don't we, so Bastian, age 9, asks, why don't we paint the rovers different colours? And then as a follow-up question for that, there was also, I spotted in the Q&A before, there was a question, why are the rockets painted white as well?
Aha. Excellent, both really good questions. So the reason why we don't paint the rovers different colours is 2 reasons. One is, you'll see when you see pictures of rovers on the surface, they all look quite shiny, and they seem to be wrapped in this gold material. And that material is there to protect the rover from the differences in heat. So the surface of Mars is very, very cold, average temperature minus 60 degrees. And the rover needs to be able to stay warm enough to operate, but also to get rid of enough heat to not overheat when you've got effectively computers inside running really, really fast. So everything that we send up into space tends to be covered in what is basically a slightly more technological version of an emergency foil blanket. And what that does is it reflects heat off to stop things overheating, or it reflects heat back in that's being generated by the rovers to keep that rover at a good temperature. The other reason we use that is because it's light. And as Jackie said earlier, you know, literally every gram you can shave off of a space mission will save you money. Now, if you are looking at painting things, particularly we'll look at rockets in a minute, I can't remember which rocket it was, but there was one rocket that had been painted with a kind of slightly stylistic design. And even the space shuttle, the early space shuttles, their external fuel tank was painted white to match the rest of the shuttle. And then they realized that by not painting it, they were saving over a ton of mass just by not putting that paint on it. Now, the reason that rockets are painted white is largely, again, to do with heat. It's to make sure that they're not going to be absorbing too much heat on launch. Black is really good at absorbing heat. So I don't know if you've ever been out on a really hot day wearing a black t-shirt, your black t-shirt will get really hot. If you wear a white t-shirt, you tend to be a bit cooler. It reflects that heat away. So one of the reasons why they're painted white is because it is really good at preventing your rocket from overheating, which you don't want. Another reason is it makes it really easy to see against the sky when it's launching. So there's a little bit of a kind of a monitoring thing going on there. And the other reason for that is that the insulation they tend to use on things like the space shuttle is white anyway. So they don't want to paint it to add extra mass.
Amazing.
Thanks, Sophie. You have got, I don't know how much information you have in your brain, but it's just astounding. We're going to stick to the careers theme for some of the next questions. Barnabas, you've had your hand up for a while. Would you like to ask your question directly? Can you speak? Can we hear you?
Where do I start if I want to be an astrobiologist?
Aha,
very
good question, Barnabas. So where you start if you want to be an astrobiologist is you start principally with biology. So all the astrobiologists, their main job is studying biology on Earth and then figuring out how we could look for the most extreme versions of that would be likely to be found outside. So most astrobiologists start off in biology. Chemistry is also really important. Understanding how all the chemical reactions that go on inside living things happen, what affects those chemical reactions. So if you want to be an astrobiologist, start getting really into biology and chemistry, you know, borrow a microscope, even just taking a magnifying glass outside, have a look at little tiny critters. If you search online, you can actually find tardigrades, these little water bears. You can find them in the UK in moss. So there's an activity, if you Google it, to let you actually find and look at these ridiculously hardy little microorganisms. So get into biology and chemistry. As you get potentially a little bit older, universities will do things like summer schools where you can go along and spend a week learning really in depth about a particular topic. And some universities in the UK actually run, I know the University of Edinburgh does, and I know other ones do as well, they run specific astrobiology ones. So you can go along and be with a whole bunch of other young people who are all interested in looking for life in the universe. And that will be a really good way of getting yourself some more information and experience as well.
Great, Barnabas, I hope that answered your question. I must admit, astrobiology is so fascinating. I mean, it's a proper job looking for alien life and trying to understand what life is on our world as well. It's just brilliant. Anyway, thank you, Barnabas, for a really good question there. And another question, which I think is an excellent one, is from Otis, who asks, what's the hardest job in NASA? And I'm going to just say, or ESA. So obviously ESA is the European Space Agency that we're part of. Go ESA. NASA is the American. So we're gonna think about if you wanted to work in NASA or ESA, what do you think is the hardest job?
Oh, it's a tricky question. I can tell you, I think one of the hardest jobs, just because of the pressure and the stress of the job, would be being in charge of the human exploration programs. So if you are the person, so in the European Space Agency, we call them directorates. All the different areas are different directorates. You've got one for robotic exploration, you've got one for astronomy, you've got one for human spaceflight. And the previous, because there's a change in that coming up, the previous incumbent came and spoke at the National Space Academy a couple of years ago and said that one of the his job was for very short periods of time the most stressful job on the planet, because the responsibility of a human launching on a rocket falls to them. If something goes wrong, it's them that has to deal with everything, and they have to try and ensure that they're safe. So that would be a pretty tricky job, in my opinion. I think the key thing with all the space jobs is they're all hard in their own way, but that makes them challenging and interesting in their own way as well. So, if you are a rocket designer, that's really difficult because you have to be trying to design things for the space environment that you can't easily test unless you're out in space. So I think all the jobs have got difficulties and all the jobs have got really interesting things. But from my point of view, I think just because of the responsibility of it, I think I would struggle in a role like being in charge and heading up human spaceflight.
Yeah, it's a big responsibility, isn't it? I think I don't know if my nerves could take it either. So we've got a question here from Jarvis Brooke from Year 4, and I think that you're going to unmute yourselves. It's a question from Kathy Rose to ask her question. So let me just allow you to talk. Are you there?
Can you hear us?
Yep, we can hear you.
Here's Kathy Rose with her question.
Does an astronomer study all the stars or just a few?
Great
Another
question.
Fantastic question. So astronomers in general study all the stars. And actually, you can be an astronomer now, because all you need to be an astronomer is the interest to look up. Yeah. So we're heading into winter. A lot of people have some extra time on their hands. Make yourself a hot drink, step outside, look up at the stars and just take interest in what you can see. Then you can go to websites like, shameless plug here, but the National Space Centre where I work, we have little guides on what you can see in the night sky, which will allow you to start to get a feel for it. So amateur astronomers, people that do it in their spare time, generally do look at all of the stars to get the big picture. If you're going off to be a professional astronomer, so if you're going to go work for a university to do research in stars, then you do tend to start specializing. One of my friends, Paul, specializes in a type of star called white dwarfs. These are the little small, incredibly hot remnants left over at the end of a star's life. And he spends all of his time looking at white dwarfs, just looking at that one type of star. Another friend of mine, Kim, works on a mission called Swift, which looks for gamma ray bursts. So she looks just for the flashes of intense radiation that you see when you get a supernova. So she spends her time tracking the sky for these type of stars at the end of their lives. So effectively, as your career in space develops as an astronomer, you gradually specialize more and more in the kind of stars that you're looking for, because, you know, the whole point of an astronomer is to find out new information about certain areas and to learn things that we don't know yet. And you do that by specializing more and more as your career progresses.
Now, I noticed that we're 1 minute past our time, but we thought because we've just got so many questions that we would just carry on another 5 minutes. So if you are able to stay with us for another few minutes, we'll try and get a couple more questions in. And then, Sophie, I don't know, but is there a way in which people can ask their space question to the National Space Centre, or perhaps having a look at where you are on Facebook? Would that work?
Absolutely. So the National Space Centre, we are a visitor attraction in Leicester that is all about space, and we work with the Space Research Centre at the University of Leicester. We have, because of lockdown and everything, moved all of our content online recently, and we have very regular Q&A sessions on our Facebook page. So if you follow us on Facebook and or on Twitter, you'll get updated on when we're doing that. Our next one coming up, I haven't got the date to hand, but our next one coming up is with Samantha Cristoforetti with the European Space Agency Astronaut. So I'm looking forward to that one. That's going to be fun. Last week we had Professor Charles Cockell, who was an astrobiologist. Week before that we had Tim Peake. So we get specialist space guests on who talk about their areas, and then for the last half hour or so, much like this, we open it up to general space questions as well. So that's probably the easiest way, is to follow the National Space Centre and the National Space Academy, particularly if you're interested in careers. We do a lot of career stuff for the National Space Academy. Just look for us on social media, give us a follow, and you'll have loads of opportunities to ask you questions.
Brilliant, brilliant. And I also just want to say to anybody who's saying, please ask my question, if you are an anonymous person, we don't know which question it was that you asked. So for anyone who is desperate, I'm afraid to say I'm not entirely sure which question it is that you asked, because you're anonymous, which is really tricky. So we will try and get to your question. Hopefully we'll get to it. Now, Ansh, you have had your hand up for ages. And so I would like to allow you to talk. Hopefully you can speak now and ask your question.
Yeah, my question is that how can we create life on the Mars?
Ooh, now creating life on Mars, that's difficult because we're still not 100% sure how life was created on the Earth. So one of the things that astrobiologists are doing, as well as looking at extremophiles, is trying to figure out what were the mechanisms for life. How did we go from having this collection of molecules? What was it that sparked the energy interactions that allowed them to turn into a cell, which was then able to turn into more complex organisms? There's still a lot to learn about that. One thing that we are beginning to think about is not about creating life as such, but how could we adapt life on Earth to be able to use on Mars? So one of the things that Professor Charles Cockell is doing is he's looking at creating bioreactors. So basically taking little tiny microorganisms that are able to eat rock effectively and turn it into more useful substances. So he sent one experiment up to the International Space Station, and they are now scoping up possibilities for sending an experiment to Mars in the future. So it's not so much about creating life, it's about how can we adapt life or provide an environment to allow that to happen. And that takes us into a whole new area of planetary exploration called terraforming, or making planets more Earth-like or more habitable. And I could go on for hours for that, but I know we've got lots of questions to get onto. But if you want to look into that in more detail, have a look at terraforming. And there are already some ideas of how we could adapt and change the Martian environment to allow life to be able to flourish and develop there.
Great. I don't know, Sharon, have we got time for one more live-ish question.
Hello.
Hi.
Hi, Amy.
Hi. How many astronauts have you sent to space?
Oh, I don't have the exact number off the top of my head. Last time I checked, it was somewhere in the region of 570 in total. But we've sent quite a few up recently with SpaceX. Jackie, do you have the current number?
I don't. I think it was near the 600 mark last time I checked. But yeah, I don't have the number to hand. But normally, I think Wikipedia or Google are quite quick in updating this number anyway. So if you give it a quick Google, you might come up with either the last number before the last mission or the most recent number now. But yeah, it's over 500, between 500-600 astronauts.
Thank you.
You're very welcome.
Well, thank you. In fact, thank you all for being here, and thank you all for asking all your questions. I think
Great
there's
questions,
such good questions. Like, and completely, I really hope that some of you become our next space researchers and scientists and chefs and designers, and it's an amazingly diverse field. And I love the idea that if you can think of a job down here on Earth, there's a space version for you. So there you go. Space dentist, space.
Very quick update on the number of people. Lucinda has just checked. I was so nearly
You were
spot
so
on.
close.
Yeah.
Yeah.
569.
569.
I was way off. I don't know what numbers I was looking at. I was thinking too far in the future.
So if you want to ask some more questions now, this is the last of our school session. However, we do have 3 more sessions for National Astronomy Week. One is at 6 o'clock tonight, and it's Ask an Astronomer. So people who are studying stars, who are looking with huge telescopes on Earth or out based in space, looking at the stars and trying to understand the cosmos, you can ask them any questions. That's at 6 o'clock live tonight. And tomorrow at 6 o'clock, we have a session all about the science fiction of Mars. Ooh. And on Sunday, our very own Lucinda, who is an absolute Mars expert, is going to do a session all about sending humans to Mars. And as Sophie said, there is the thought that whoever goes to Mars is probably in primary school at the moment. So maybe it's someone listening now. So maybe you should tune in for that as well. But for the meantime, it's my job to say thank you so much to Sophie, and thank you so much to Jackie, and thank you so much to all of you joining us this Friday. And we hope you have an amazing end of the week and enjoy the weekend. So goodbye for now.
Thanks, Sharon.
Goodbye.
Goodbye.
Bye.